Welcome back guys. Today we are going to analyze and design a G+2 building with dead load and live load. These are the given details. The height of the building is given as uh, height of the building with a floor height of 3 meter for each floor. The building is of G plus 2. So the ground floor will be having a 3 meter, first floor 3 meter and the second floor 3 meter. Total will be 3, 9 meter. Width of the building with 3 bays at 4 meter each. So for the ones who don't know the meaning of a bay, it is the gap between two columns. I'll show you. I'll take a shape here. Shape. So this is our first column and let it be the second column. So this distance between two columns is known as the bay. So width of the building with 3 bays at 4 meter each. So the distance between the bays in our case is 4 meter. A bay is of a 4 meter and there are 3 bays. 4, 4, 4. Total it is 12 meter. The third one is column size 0.38 by 0.38 and the beam size is 0.46 by 0.46 meters. Yeah, footings are 2 millimeter below the ground level. Plinth beams 0.23 by 0.438 meters. Yeah, length of the building width. So we have to increase the height of the building 9 plus 2 with level. Yeah. So the length of the building with 5 bays at 5 meter each. Okay. So the length means it's in Z direction. 5 bays at 5 meter means 5 5s are 25. The length of the building will come out as 25 meter. Yeah. There are dead loads, which is floor thickness 150 mm. Floor finish 1.5 kilonewton per meter square. Wall load is 15 kilonewton per meter. Live loads are 3 kilonewton per meter square. Make a note down of the question. Now we'll head towards the STAAD Pro. In the startup page of STAAD Pro, give the file name as something XYZ building G+2. Select the location. Take the units as metric as we'll be working in the metric system and click on create a job. A window will be opened. The STAAD Pro will be opened. Here we simply have to do is go to the structural wizard. Here in the left corner we have structure wizard. Click on the structure wizard. A new window will be opened. Here go to the file, click on select units, select it as meters again. Now go to the model type and select frame models. Here we will be taking a bay frame. Take the 25 meter, height will be level meter. We'll change this as 5, 3, 3. Okay. So the width of the building is given as 4 meter with 3 bays. 3 number of bays are 3. Let's put 3 are 12. So yeah. We have designed our base. Yeah. Now it is okay. We'll simply go to the file and click on merge model with STAAD Pro model. Click on yes. Okay. So our model is ready. This is our building with this is the height of the building, this is the length of the building, and this is the width of the building. Height is of 3 bays, First is 5 meter, including the plinth beam, and the second is 3 meter, which is the first floor, and the third is second floor with a 3 meters height. And along the length, we have 1, 2, 3, 4, 5 bays at 5 meter each. And along the width, we have 3 bays at 4 meter each, which makes it to 12 meter. Now, go to the properties section. We have columns, beams, and plinth beams. Go to the prismatic. Here, go to the rectangular section. 1 minute. Yeah. After going into the rectangular section, we'll first add the beam dimensions, which are given as 0.23 meters by 0.6 meters. Add. And next, we'll add column dimensions, which are given as 0.38 by 0.38 meters. And now we'll add the plinth beam dimensions, which are given as 0.23 by 0.38 meter. Click on add. Now, the view, go to the view panel and change the view to the front view. Here what we'll do is, we'll click on this property, go to the select, go to the beams panel, click on parallel to X. These beams will be selected, assigned to the selected beams. If you go in the 3D view, the beams in all the directions are selected. In these directions are selected, but not in these directions. So we have to again go to the select, parallel to, yeah, this is not working, 1 minute, parallel to Z. Now, as you can see in the building, all the beams have been selected. Now we can assign this property, assign to the selected beam, assign, yeah. Our first property is assigned. Now we'll assign the columns. To assign it to the columns, click on parallel to Y. Simply, all the columns will be selected, and click on assign to selected beams. Assign. Yeah, all the columns have been assigned. Now for the plinth beams, we'll add the property to these beams. So go to the front view. Simply select these beams with your cursor. Left click on your cursor. Only those beams will be selected and assign the property. Yeah. Now we are done with assigning the properties. Yeah, we'll leave this materials and the specifications part because it default takes as concrete. We'll assign the supports. To assign the supports, we have to create one supports. Click on fixed. Yeah. We need fixed supports to be assigned on the bottom. So we'll change the view to the front view. Simply take your cursor and scroll it like this, and these nodes will be selected, and you can see in the 3D view all the nodes, all the columns which have been selected. So now you can assign this support. Yeah, our support part has been completed. Now here comes a most complicated part. It's easy. We'll go to the loading panel, load case details, add. First load is dead load. We'll change the title to dead load. Click on add. Live load. Change the title to live load. Click on add. Close. In the dead load, firstly we have to add the self weight of the structure. It will take the factor as -1 automatically. Click on add. Now As per the question, the dead load is floor finish of 1.5 kilonewton per meter square, and the slab thickness is given as 150 mm. So if we take the slab thickness as 150 into the unit, sorry, point 150 mm into unit weight of RCC, which is 25 kilonewton per meter cube. So converting it to the meters, 0.15 into 25, we'll get 37 kilonewton per meter cube. We'll assign the self weight, assign to view, assign. Now select the dead load, click on add. Here we'll go to the floor load and our range is 37 kilonewton per meter square. Define Y range. The Y range means the length of the building. So minimum is 0 and the maximum is 11. X range is the length of the building, which is 0 to 25, and Z range is the width of the building, which is 0 to 12. The global Y direction. Click on add. The other one is 1.5 into floor finish. What is it called? 1.5 into 25. This comes as 37.5. Sorry, I made a mistake here. It is 37.5, which is 0.15 the slab thickness into, sorry, 1.5 kilonewton per meter square into 25, which comes as 37.5. You can add. And the second one is 0.15 into 25, which comes as 3.75. Click on add. Yeah. Delete this 37 one. Yeah. 37.5 and 3.75. As you can see, there is a beautiful design on the floor of the buildings. It comes when you add the loads. Yeah. There is a wall load on beams of 15 kilonewton per meter. So click on dead load, click on add, add. Take the member load, uniform force. It is a 15 kilonewton per meter. Click on add. Now we have to assign this to the walls, only the walls, exterior walls of the building. So we'll go to the select option, the beams parallel to X and the parallel to Z. If we do it in this way, the load will come onto the topmost floor also, but we need to do only in the first floor and the second floor. So we'll simply change the view to the front view. We'll select these beams. No, it's not getting selected. Yeah, control, click on control and select these also. Yeah. Oh, not this. Yeah, we're doing correct only. Click on this, click on this, assign to the selected bits, assign. Yeah, I'll select on view loading diagram. The problem is we have given 15 kilonewton per meter. We should have given it as minus 15. Modify, close. Yeah, and the floor load is also okay. I think so. Let's do it minus 1 minute. What is the option? No, it is plus only. Yeah, this is our loading diagram. We have not completed. Now we'll add live load. Live load is 3 kilonewton per meter square. Click on add. We'll add it as a floor load only. Just 3 kilonewton per meter square. 0 to level, 0 to 25, 0 to 12. Click on add. Close. Yeah. It should come like this. Okay. Our loading part has been completed. We'll go to the analysis. Go to analysis. Select the view as 3D view. Analysis. Give analysis command. Add. Close. Now run the analysis. We'll see if we get any errors. It's processing. No, we have zero errors, zero warnings. Now we can go to the post processing mode. Here you will get the FY, MZ, FX, MX, MY, FZ, any value you want. Shear forces, bending moment, utilization ratio, displacement, deflection, everything. Now we'll again go to analytic modeling, go to the design, select the material as concrete, click on here, IS 456 2000, define parameters, we'll take FCS 25,000 and 25 grade, FY minus 415000, FY secondary as 250,000. Maximum main will it is a G plus 2 building, so we'll take 20 mm. Add maximum secondary 16 mm. Add minimum main again 16. Add minimum secondary 12 mm. Add. Yeah. Here go to the commands. Design beam. Add. Design column. Add. Close. Assign this to the assign to view. Click on this. Click on assign to view. Assign. Similarly to all the parameters. Now, when you assign the design beam and design column command, you have to select beams and columns. Only beams different and on columns differently. So go to the select option, parallel to X and parallel to Z, by which all the beams are selected. You can assign to selected beams. Now in the design column, then go to the parallel to Y. Columns have been selected. Click on assign. Go to the analysis. Click on analysis command. Add. Now run analysis again. Check for errors. Here we have completed our design part. 40 warnings, but you can ignore them. Now simply double click on any beam to get the concrete design. If any beam doesn't show you the concrete design, which means you have to change the properties of that section. Yeah, concrete design, yeah. This is beam number 114, design code IS 456. It has provided us the detailing of the reinforcement. Thank you. Please like, share and subscribe to my YouTube channel.